Good evening, ladies and gentlemen. This is Professor David J. De Los Reyes. It's been a long time since my last long video format topic, doing something lecture on the word. So for tonight, I will be discussing a long video format topic. It's an additional thing on my long video format topics, and this will be under the study of the so-called geometry. So the topic for tonight will be composite figure. Composite figure meaning the geometrical figures comprises of many figures. It could be a triangle, maybe a square or a semicircle. So the main topic for tonight is actually the computation and how to compute for the total area of a composite figure if that figure represents three different figures actually interconnected with each other. Okay, let's proceed with the topic for tonight. Composite figure, right? So in here, I will be presenting a problem that falls under geometry, and this falls under composite figure. We are given a figure here, okay, and this will be the figure. The top portion is a right triangle, the middle portion is a square, square, and the bottom portion is actually a semicircle. The problem here is asking what will be capital letter A with subscript T, meaning the total area of the composite figure, meaning the total area of this one here. Okay, that's the first area. The second area is this one here, and the third area will be the bottom portion, which is actually a semicircle. The problem is just asking what will be the total area. Okay. The given dimensions, this is 9 inches for the square. The other side is also 9 inches. It's a square, right? So this should be 9 and this is 9. And for the top portion, the hypotenuse, the slanting side, is actually 12 inches. For the bottom portion is actually a half semicircle or half circle. So it's a semicircle, right? Of course, we are now given the dimension of the semicircle. The diameter should be 9 inches because it's a semicircle, right? So the diameter is actually 9 inches. So if we try to bring out the solution for this one, the total area is represented by the dotted lines, actually area number 1, area number 2, and area number 3. So to bring out the solution, it is something like this. Total area, meaning capital letter A with the subscript T, will be capital letter A with the subscript 1, the top portion, capital letter A with the subscript 2, the middle portion, and the capital letter A with the subscript 3 is actually the bottom portion. So total area will be represented by, I will repeat it, area subscript 1, area subscript 2, and area subscript 3. And unluckily, the three different areas are actually different from each other. That's why our topic for tonight is actually composite. Okay? They are of different configurations. Okay, let's try to start with area number 1. For area number 1, since this is a right triangle, this should be the right angle here. Okay, and if we try to recall the formula on how to compute for the area of a right triangle, or any triangle for that matter, it will be 1/2 of the base times height. So the base of the right triangle is actually this one here, 9 inches. Okay, so in here, the base is actually equal to 9 inches. And how about the height? The height is this one here. We are not given the height, but we could compute for the height because we are given the hypotenuse and we are given the base, which is the adjacent side, considering this angle here. And by using the Pythagoras principle, we could compute for h. So h now will be the square root of the square of the hypotenuse minus the square of the adjacent side, which is 9. And this is actually 144 minus 81, and this is actually 63. And the square root of 63 is 7.93 inches. So the unknown height of the right triangle, the top area, is 7.93 inches. So we can now proceed with the computation of area number 1, the top portion. Area number 1 now will be by following this formula. 1/2 of the base is 9, and the height is 7.93 inches. Okay, we take the product of this divided by 2. So this is approximately 9 times 7, this is almost 8, is 72 over 2. It's almost 35 something. Okay, so area number 1 is 35.71. This is n's to the second power. In engineering, we read this one as square inches, because the unit of area is actually a unit length times a unit length, so it should be a unit length quantity square. And since the unit length is actually inches, so area number 1 will be 35.71. I will try to read this one square inches. Okay. How about area number 2? Area number 2 is there's no problem because we are already given the dimension of the second area is actually a square, so this should be a 9 by 9. And if we try to recall the formula and how to compute for the area of a square, it's actually the product of a length times width. Or this will just be simply, because the length and width are actually the same, so it will be side square, in which the length is equal to width is equal to the side, if the given configuration or figure is a square. So since length is equal to width equal to s, area number 2 will just be simply the side square. And since the length of the side is 9 inches, so this will be a 9 inches times 9 inches. If we try to take the product, that will be 81, like what I said a while ago. This is read n's to the second power. In engineering, we usually read this one square inches. So area number 2 is actually 81 square inches. Okay. How about area number 3? Area number 3 will be a semicircle. Okay. And for a circle, the area is actually, for a circle, the area is actually pi over 4 times the square of the diameter. That is for the whole circle. But since we are only taking a half circle or semicircle, we must have to get 1/2 of that one. So the area of the semicircle is actually 1/2 of the square of the circle. And we are given the diameter of the circle. And this is actually equivalent to the side of the square, which is actually 9 inches. Okay, so by following this formula, this should be 1/2 times the product of the quantity, open bracket, pi over 4, times the quantity 9 square, close bracket. If we try to simplify this one, okay, the area of the semicircle is actually 31. We read this one in engineering square inches. So the total area now will just be simply the summation of area number 1, area number 2, and area number 3. So we place it here, capital letter A with the subscript T, meaning the total area of the composite figure will be area number 1, which is 35.71, plus 81, the area of the second figure, which is a square, and the area of the semicircle is actually 31.8. And if we try to take the addition of this summation, this will be approximately 35, 40, 40, almost 40. It's 120 plus, and the total area, if we take the summation of this one, it's 148.51. This is n's to the second power, or this is read in engineering square inches, or the total area is 148.51 square inches. Okay, that's it, guys. That is the way on how to compute for the area of a composite figure. If the composite figure comprises of different figures, actually, that's why it's a composite figure. That is for tonight. This is Professor David J. De Los Reyes. Good evening from Los Angeles.